Let's do a quick recap. This symbol stands here for the sum of terms from the first term to the nth term. So I've written all the terms individually, and this step here I've multiplied both sides by r. Okay, so I multiplied this side by r. Okay, then I've got to multiply all of this by r as well. So I had to multiply each individual term by r because there are plus signs in between. Because to get this, you would have had to add each term. So let's say you had a geometric series that went 1, 2, 4 and up to 1024. You would have to add 1 plus 2 times 4 plus 8. Okay, and then you would have that number here, and that number, if you multiply it by r, is equal to each number here being multiplied by r and then added. Okay, now here's what I'm going to do next. I'm going to call this whole thing, equation, equation 2. I'm going to call this whole thing equation 1, and I'm going to do this. I'm going to subtract equation 1 from equation 2. Alright, so I'm going to have r Sn minus Sn is equal to, right, I can only take similar terms. Now I can't take AR, I can't take A away from AR, but I can take AR away from AR. Okay, so let me use a different color. So this and this cancel. I can take away AR squared from AR squared. This and this cancel, and there surely ought to have been an AR cube here for this AR cube to disappear. And then there surely ought to have been an ARN minus 2 here for this ARN minus 2 term to disappear. And then ARN minus 1 gets cancelled with ARN minus 1, but there is definitely no AR to the power of n, because if you're just writing the sequence, you never get an AR to the power of n. But in this sequence, because we multiplied both sides by AR, you just get ARN. Okay, you don't get the n minus 1. So all these terms, these terms in between must have got cancelled out with these terms here. Alright, and all you're left with is just this and this. Because we are taking away this away from this, you would say oops, that's the wrong color, ARN minus A. Alright, and because all the other terms are cancelled. So if I were to factorize as A, I would be left with ARN minus 1. Similarly, if I were to factorize the Sn here, I'll be left with Sn r minus 1. And I'm trying to make Sn my subject, so therefore Sn is equal to A times Rn minus 1, everything over r minus 1. And that's the equation that you use to work out the sum of terms up to a certain term in a geometric sequence. Okay, and A here stands for the first term, R stands for the common ratio, N stands for the number to which you want to add that add the terms to, the term to which you need to add to get the sum of that sequence. Alright, so let's look at an example and then you'd understand it better. Alright, so let's look at an example. I'd say in this sequence my first term is 2, my common ratio is 3, and I want to know the sum of terms up to the 6th term. Alright, so I want to know what the sum is to this sequence up to the 6th term. So you could do it manually, but we are now trying to use the formula to work it out straight away. Okay, so I'm going to say S and I'm going to say 6 here because I want the sum up to the 6th term. The first term is 2, R stands for common ratio, which is 3, and N here is just N alone, not like N minus 1 in the term in the formula that you use to find out the term itself. There it's N minus 1, but here in this formula it all just boiled down to this, and you only had R to the power of N. So N is just basically 6 minus 1, everything over 3 minus 1. So if you solve this, you'd get the answer to this, the sum of the first 6 terms. Alright, if you solve that, you get this result. And the next step is this. So you've just ended up with 728. Okay, so that's just a quick introduction on geometric series, how to find the certain term of a geometric sequence, and also to find the sum of terms up to a certain term